A huge welcome to all our listeners out there. And, we got to give a special shout out to the fantastic audience over at the Tech Unplugged podcast by Sublime Techie.
Yeah.
Seriously, we're big fans. You guys do an amazing job of breaking down complex tech stuff and making it actually understandable.
Making it for everyone.
Exactly, which is what we try to do here, too. And today we're going to dive deep into a world that's, well, a little bit out there, literally, satellite cybersecurity.
Yeah, it's a critical area. And it's only getting more important.
Definitely more important. And you know what? Most people probably don't even realize how much they rely on satellites every single day.
It's true. It's not just about, using GPS to find your way around anymore.
Right. I mean, GPS is a lot more than just directions on your phone. Do you know that GPS is what keeps our financial markets running smoothly?
Yeah, it's all about the super precise time synchronization. Same thing with mobile networks.
And let's not forget about navigation for planes and ships. Or those weather forecasts that, well, sometimes save our weekend plans.
And they can save lives, too.
Absolutely. Think about disaster monitoring and relief efforts. Satellites play a huge role there. And of course, we can't forget about, the internet, TV, radio, all that stuff that keeps us connected. It's all thanks to those little boxes orbiting way up there.
We're pretty dependent on those orbiting platforms.
Big time. And that's why you got to talk about cybersecurity, right? I mean, think about it. The more we rely on something, the more attractive it becomes as a target.
Yeah. And when you talk about hacking satellites, I think a lot of people probably imagine, some Hollywood movie scene.
Lasers and explosion.
Exactly. But the real threats are way more diverse than that. And they go way beyond just the satellites themselves.
So we're talking vulnerabilities across the entire system.
The whole thing. The satellites, the ground stations, the communication links, everything's a potential target.
Okay, so let's try to break all this down. What are, the biggest categories of threats we need to be aware of in satellite cybersecurity? I mean, where do we even begin?
Well, I think a good starting point is to think about what are called ASAT capabilities.
ASAT?
Oh, yeah, anti-satellite.
Yeah.
Now, some people think this only means, physically blowing up a satellite, which, is definitely a thing, the kinetic threat, as it's called.
Right, right.
But there's also what we call virtual or cyber methods.
So attacking a satellite software and system.
Exactly. Messing with its digital brain, so to speak. And then you've got hybrid approaches, which kind of combine the two.
Like using a laser to blind a sensor. Or like an EMP blast to fry its electronics.
You got it.
So it's not just about rockets hitting satellites. The digital domain is a whole other battleground.
Oh, yeah, definitely. And a growing one. I mean, think about it. There are over 1,000 operational satellites up there right now.
Wow.
Yeah, and that number is just going up.
Yeah.
And as you can imagine, that means more potential for, instability.
Makes sense.
And, one interesting thing is that cyber threats are actually becoming the dominant form of potential conflict in space.
Oh, really?
Yeah. Because think about it. If you blow up a satellite,
Yeah.
you create a ton of debris.
Right, space junk.
Exactly. And that debris can stay up there for a long time, posing a danger to everyone's satellites, including your own. So there's kind of a built-in deterrent against using kinetic weapons in space.
It's like nobody wants to pollute their own backyard, right?
Right.
And I've heard that, getting into space is getting cheaper and easier these days. The barriers to entry are lower.
That's definitely true. The cost of launching stuff into space has come down a lot, and the satellites themselves are getting smaller. Think miniaturization.
So more players can get involved now.
Absolutely. It's not just superpowers anymore. Smaller countries, companies, even research institutions can put satellites up there.
That's cool. But I guess it also means more potential vulnerabilities.
Yeah, unfortunately. More actors, more systems, more potential points of weakness.
Okay, so we've got more targets and more ways to reach them. Now let's talk specifics. Where are the vulnerabilities? Are we mostly worried about somebody hacking into a satellite while it's in orbit?
I mean, that's definitely a concern, but it's not the whole picture. Think about it. Vulnerabilities exist across the entire architecture.
From the satellite in space to the ground station down here.
Exactly. It's a whole chain.
Yeah.
And we can basically break down the vulnerabilities into 3 categories. Threats to the satellites themselves, threats to the ground stations, and threats to the communication links between them.
Okay, that makes sense. Let's start with the satellites. What kind of attacks could a satellite face while it's up there?
Well, there are a few different ways you could attack a satellite directly. One is by targeting its control systems.
Like actually taking control of the satellite?
Yeah. Think about it. If you can gain unauthorized access to the control systems, you could potentially send commands to change its orientation, its orbit, even its mission objectives.
That's kind of scary.
Yeah. And one scenario that's particularly concerning is the idea of a backdoor being planted in a satellite component,
A backdoor.
like a hidden piece of code that allows an attacker to take control.
So it could be hidden in like a scientific instrument?
Exactly. Something that seems totally harmless. And then, boom, they trigger the backdoor and send a command that makes the whole satellite spin out of control.
Wow. That would be a disaster.
And then there's the risk of hardware backdoors.
Meaning?
So imagine somebody inserting a malicious chip or component during the manufacturing process. You wouldn't even know it's there until it's activated.
That's sneaky.
And then you've got the threat of bespoke malware.
Bespoke.
Yeah, malware that's specifically designed to exploit vulnerabilities in a particular satellite software.
Oh, so it's not just random viruses floating around.
Right. It's targeted.
Yeah.
And then there's something called payload hijacking.
Payload hijacking.
Yeah, that's where an attacker takes control of the satellite's sensors, the instruments that collect data. So let's say a satellite has a really powerful camera for, like, Earth observation. An attacker could hijack that camera and use it to take pictures of things they shouldn't be looking at.
Oh, I see. So it's not just about destroying the satellite, it's about actually using its capabilities against us.
Exactly. And that's a pretty significant shift.
Okay, so those are some pretty serious threats. What about the ground stations? Are those vulnerable too?
Oh, yeah, definitely. Ground stations are basically just really sophisticated computer networks.
Like server rooms and stuff.
Right. And they're susceptible to the same kinds of attacks that any network can face.
So hackers trying to get in?
Exactly. They could try to, like, phish employees, trick them into giving up their passwords, or they could exploit vulnerabilities in the software. And let's not forget about physical security. If somebody can actually get into the ground station, well, they could do a lot of damage.
I guess they could, like, tamper with equipment or install malicious software directly?
Exactly. And, ground stations are often what we call single points of failure.
Meaning?
Meaning that if you take out the ground station, you take out the entire satellite system.
Wow.
And, there was actually a documented case where a Raspberry Pi, like a tiny little computer, was used to gain access to a sensitive network at NASA's Jet Propulsion Laboratory.
A Raspberry Pi.
Yeah. It just shows you that even seemingly small things can be exploited.
That's wild. Okay, so we've got satellites and ground stations. Now, what about those communication links? The stuff that sends the signals back and forth.
Right. So those links are vulnerable to a whole range of things.
Like what?
Well, one classic tactic is jamming.
Jamming.
Yes, basically flooding the signal with noise,
Yeah.
making it impossible to communicate.
Oh, so like blocking the signal.
Exactly. It's an old tactic, but it's still very effective. And there have been documented cases of, like, Russia using GPS jamming during NATO exercises.
Wow.
Yeah, and that jamming affected not just the military, but commercial airlines too.
So it disrupted civilian flights.
Yeah. And then you've got eavesdropping.
Listening in.
Exactly. Intercepting and decoding the signals.
Is that even possible?
Oh, yeah. Researchers have actually shown that you can intercept satellite broadband signals using, like, off-the-shelf home TV equipment.
Seriously? Seriously?
So people's internet traffic.
Yeah, potentially. Especially if it's not encrypted.
That's creepy.
Yeah, it is.
Okay, so jamming, eavesdropping.
Yeah.
What else?
Well, there's something called signal injection.
Signal injection.
Yeah, that's where an attacker tries to insert their own malicious data into a legitimate transmission. So it looks like it's coming from a trusted source.
Jakey?
And then there's signal spoofing.
Kaboofing.
Yeah, that's basically faking a signal.
Yeah.
So, for example, GPS spoofing.
So you could trick a GPS receiver into thinking it's somewhere else.
Exactly. And that can have some pretty serious consequences, especially for things like, autonomous vehicles.
Right. If your car thinks it's on a different road.
Yeah, not good. And the crazy thing is, a lot of this stuff can be done with relatively inexpensive equipment. So it's not just nation states with, like, unlimited resources.
Nope. It's a lot more accessible than you might think.
Okay, so securing these satellite systems, it sounds like that presents some pretty unique challenges.
It does. It's not like securing a regular computer network. You can't just apply the same old cybersecurity best practices.
Right, because you're dealing with, like, the harsh environment of space.
Exactly. And you've got things like radiation, extreme temperatures, all that stuff.
Makes sense.
And then there's the issue of supply chains.
You mean like all the different companies involved in building a satellite?
Yeah. I mean, think about it. A satellite might have components from dozens of different suppliers all over the world.
Right.
And any one of those components could have a vulnerability. or even a deliberately planted back door.
That's a lot to keep track of.
It is. And then there's the use of commercial off-the-shelf hardware, COTS as it's called.
So using components that are like mass-produced.
Exactly. And while that can be cheaper and more efficient, it also means that if a vulnerability is found, it could affect a lot of different satellites.
Right.
And patching those vulnerabilities in space can be a real pain.
I bet.
And on top of all that, there's just a general lack of expertise in space cybersecurity. I mean, there aren't that many people who understand both the cybersecurity side and the space side.
Right. It's like a niche within a niche.
Exactly. And then, satellites themselves are often resource constrained, meaning they don't have a lot of processing power, storage space, or bandwidth.
Yeah.
So you can't just load them up with all the latest security software.
Right.
And finally, there's the challenge of just figuring out what's going on. I mean, if something weird happens, is it a cyber attack? Or is it just a random glitch caused by, space weather or something?
That sounds like a tough one to figure out.
It is.
Okay, so we've talked about the threats and the vulnerabilities. Now let's talk about the actors. Who are the people who might actually try to exploit these weaknesses? And what are their motivations?
Right. Well, the motivations are actually quite varied.
I guess it depends on who's doing it.
Exactly. So for nation states, a big motivator is, national pride.
Like wanting to be the best in space.
Exactly. They want to show that they have the most advanced technology, and they want to be able to, control space.
Makes sense.
And then there's economic gain.
Like stealing secrets or something?
Yeah, that's a big one. Stealing intellectual property, disrupting a competitor's satellite services, even things like, asteroid mining in the future.
Asteroid mining?
Yeah, it sounds crazy, but people are thinking about it.
Yeah, okay.
And then there are political activists.
So people using satellites to make a statement.
Yeah.
Like trying to disrupt a broadcast or something. There was actually a case where the Falun Gong spiritual group hijacked a satellite TV signal to broadcast their own propaganda.
Wow.
And, of course, there are always military objectives.
Like disrupting communications or gathering intelligence. Exactly. There's a suspected Russian satellite called Lurch that's believed to be an eavesdropping platform.
A space spy.
Basically.
And I guess we can't rule out terrorism.
Unfortunately not.
Yeah.
I mean, attacking a satellite could be seen as a way to undermine public confidence or cause widespread disruption.
Yeah, that makes sense.
And then there are the more personal motivations, like, revenge, blackmail, that kind of thing.
So a disgruntled employee could cause some serious havoc.
Absolutely. And then there are some people who just have, ideological reasons for wanting to attack satellites.
Like anti-technology folks.
Yeah. People who think that technology is inherently bad.
Wow. So it's not just like one type of person who might attack a satellite.
Nope. It's a whole range of actors.
And is it mostly nation states that we're worried about? Or are other groups a threat too?
I mean, nation states are definitely a concern, especially the ones with really sophisticated cyber capabilities. But we also have to worry about non-state actors.
Like who?
Well, there are hacktivist groups.
Like anonymous?
Yeah, exactly. Groups with political agendas who want to make a statement.
Okay.
And then there are criminal organizations.
Yeah.
They might be interested in, stealing financial data or disrupting businesses.
Right.
And then, of course, there are terrorist organizations.
So it's not just about espionage or warfare.
Nope. It's way more than that.
Okay, so this is all pretty theoretical.
Yeah.
Are there any real-world examples of these kinds of attacks actually happening?
Oh, yeah, definitely. One example that comes to mind is the exploitation of maritime VSAT services.
Maritime VSA.
Yeah, it's basically satellite internet for ships and stuff.
Yeah.
And research has shown that there are some pretty serious security vulnerabilities in those systems.
Really?
Yeah. Researchers were able to eavesdrop on unencrypted traffic using pretty basic equipment.
So they could see what people were doing online?
Yeah, potentially. And they were even able to hijack TCP sessions.
Meaning?
Meaning they could basically take over someone else's internet connection.
That's pretty scary.
And they were able to do all this to, oil tankers, cargo ships, even research vessels.
Wow.
And the vulnerabilities go beyond just the satellite links. There have also been cases where vulnerabilities were found in the SATCOM terminals themselves.
The actual equipment?
Yeah. Things like backdoors, hard-coded passwords, outdated security protocols, and exploiting these vulnerabilities could allow an attacker to do all sorts of things.
Like what?
Well, they could intercept communications, manipulate data, even take control of the terminal remotely.
So you could basically turn someone's satellite phone into a listening device.
Potentially. And some specific terminals, like the ones made by Cobham and Hughes, have been found to have these kinds of issues.
Wow.
And then there's the threat to satellite navigation systems, like GPS.
Which we talked about earlier with the jamming and spoofing.
Exactly. And that's a big concern for a lot of reasons. I mean, think about autonomous vehicles. They rely heavily on GPS to navigate.
Right.
And if their GPS signal is jammed or spoofed, well, that could lead to some pretty bad accidents. And then there's the potential to manipulate what's called space situational awareness data.
I so say.
Yeah, that's basically the information we use to track objects in orbit, to make sure they don't collide with each other.
Okay.
And if that data is compromised, it could lead to some pretty serious problems, like a satellite could be maneuvered into the wrong orbit, or an attacker could hide their activities in space.
So it's kind of like a stealth attack.
In a way.
Yeah.
And researchers have shown that this kind of manipulation is actually possible.
Wow.
And finally, we need to think about the risks posed by smaller satellites, like CubeSats.
CubeSats.
Yeah, they're like these tiny little satellites that are becoming really popular.
Okay.
And the thing is, they often hitch rides on larger rockets as secondary payloads.
So they're kind of like stowaways.
In a way.
Mm.
And the problem is, if a CubeSat is compromised, it could potentially pose a threat to the main mission.
Like how?
Well, it could be programmed to, jam GPS signals during the launch. Or it could even try to physically damage the other payloads.
That's pretty scary.
Yeah.
Okay, so we've talked about all these threats. What are we actually doing about them? What are the main ways that we're trying to protect our satellites?
Well, there's a lot of work being done on, developing better anti-jamming technologies.
So making it harder to block those signals?
Exactly. And there are also efforts to improve encryption.
You mean making the communications more secure?
Right. But that can be tricky with satellite links
Right.
because they have high latency,
Right.
meaning there's a delay in the signal.
Right.
And that can make it hard to use some of the traditional encryption methods.
Okay.
So people are looking at things like performance-enhancing proxies or PPs.
PPs.
Yeah, they're basically designed to improve the speed of data transfer over satellite links.
Yeah.
But the problem is they're often not compatible with encryption.
So it's a trade-off.
Exactly. But there are some new hybrid approaches being developed, like QPEP, which tries to combine security and performance.
Okay, so that's for protecting the communication links. What about protecting the satellites themselves?
Well, one of the biggest things is just raising awareness,
Hmm.
making sure that people in the space industry understand the cybersecurity risks.
Right.
And then there are efforts to improve software verification,
Meaning?
making sure that the software that runs on satellites is secure and reliable.
Okay.
And people are also working on developing better anomaly detection systems.
So being able to spot unusual activity.
Exactly.
Yeah.
And then there's the idea of classifying satellites as critical infrastructure.
Like power grids and stuff.
Right. Because if a satellite is considered critical infrastructure, then there are more regulations and security standards that have to be met.
Makes sense.
And then there's the whole debate about whether satellite operators should be allowed to hack back.
Meaning?
Meaning, if they're attacked, can they retaliate?
That's a tough one.
It is. And then there's the issue of space situational awareness data. People are working on developing systems that allow us to, cross-check the data from different sources so we can be more confident that it's accurate.
So a trust but verify kind of thing.
Exactly.
Okay, so it sounds like there's a lot going on, but it's still a pretty new field, right?
Yeah, it is. And there's a lot more work to be done.
Okay. Now, I want to shift gears a little bit and talk about something else that's really fascinating. The whole issue of commercial remote sensing satellites.
Oh, yeah, that's a big one.
Because it's not just about, protecting our own satellites from attack.
Right. It's also about the fact that other people's satellites can be used to spy on us.
Exactly.
And the capabilities of these commercial satellites are incredible. I mean, they can take really high-resolution pictures of almost anywhere on Earth.
So it's like everybody has access to spy satellites now.
In a way.
Yeah.
And that's a big shift from the way things used to be. Back when only governments had access to that kind of technology.
Right.
And it creates a whole new set of challenges.
Yeah.
Especially for, the military.
Because they're used to operating in secrecy.
Exactly. And now they have to worry about being watched from space. by anyone.
I guess that makes it harder to, like, plan and execute missions.
Absolutely.
And there's that example we came across about Iran using commercial satellite imagery after they attacked a U.S. airbase in Iraq.
Oh, yeah, that was a pretty big deal.
Could you talk about that a little bit?
Yeah, so basically, Iran was able to obtain high-resolution imagery of the airbase after the attack. And they were able to use that imagery to assess the damage and see how effective their attack had been.
And they got that imagery from a commercial provider.
Exactly. And that really highlighted the fact that this technology is no longer limited to governments.
So it's like the playing field has been leveled.
In a way. And that's a big challenge for countries that are used to having an intelligence advantage.
Right.
And, it's not just about, like, spying on military operations. This technology can be used to track all sorts of things.
Like what?
Well, you could track the movement of ships, for example.
Or like monitor critical infrastructure.
Exactly. And that raises all sorts of concerns about, like, national security and economic espionage.
So what can we do about it? I mean, is there any way to control this technology?
That's a tough one. I mean, you can't just, like, ban commercial remote sensing satellites.
Right, because there are legitimate uses for them, too.
Exactly. So it's a balancing act.
Okay.
But there are some things that can be done. Like, the U.S. has licensing procedures for companies that want to operate remote sensing satellites.
So they have to get permission first.
Right. And there are also international agreements and notification protocols that can help to manage the flow of this kind of data.
Okay.
And there's even been talk about creating a notice to spacemen.
A notice to spacemen.
Yeah, it would be kind of like a notice to airmen. You know how pilots get notices about things like restricted airspace?
Okay.
So a NOTSM would basically be a way to alert satellite operators to sensitive military operations.
And ask them not to take pictures.
Exactly. But of course, that would require a lot of international cooperation.
Right.
And it's not clear how you would enforce it.
Yeah, that's a tricky one.
It is.
Well, this has been a fascinating conversation. I feel like I've learned a lot about a topic I knew very little about before.
It's definitely a complex issue.
It is, and it's something that we all need to be more aware of. I mean, satellite technology is so pervasive in our lives.
It really is.
And the consequences of a security breach could be really serious.
Absolutely.
So what's the takeaway here? I mean, what should people be thinking about after listening to this?
I think the biggest takeaway is that space is no longer this, like, separate domain.
Right. It's connected to everything else.
Exactly. And that means that the cybersecurity risks we face in space are also risks to our lives here on Earth.
That's a good point.
And I think we need to be more proactive about addressing these risks.
Okay. So what can we do, I mean, as individuals?
Well, I think the first step is just to be aware of the issue.
Right.
And then, support policies that promote space cybersecurity. And maybe even consider a career in the field.
There you go.
We need more people working on this stuff.
Definitely. Well, I want to thank you again for taking the time to talk to us about all this.
It was my pleasure.
And to our listeners, thank you for joining us for this deep dive into satellite cybersecurity. It's a fascinating topic, and I hope you learned something new.
I hope so, too.
And please keep those questions coming. We love to hear from you. And don't forget to check out the Tech Unplugged podcast for more great insights into the world of technology.
Yeah, they're great.
Until next time, stay curious.